This is the second half of the stoichiometry slides. Right? So we've gone through in general how stoichiometry works, that one way or another you're going to get to moles, and then you're going to use balance equation to get to moles of something else, and then you're going to get out of moles. So if we're going to do a problem, this is a good example. We'll start here. So how many moles of oxygen are required to burn 2.4 moles of ethane gas? So this is where, for each of these steps, I would recommend hitting the pause button, right? And that way, because I'm going to click ahead and you can stop and then you can see. And again, as you're going through the slides on your own without the video, you can just hit the right arrow or the enter key. So hit the pause button, try to write the balance equation. So ethane burning. All right, you're back from pause. Hopefully you got that as the balance equation. Right, so now we're going to use dimensional analysis, and we're going to start, remember with dimensional analysis, say where are we going, and making sure we keep track of the units. So if we just set up the problem, we're going to go from 2.4 moles of ethane gas to moles of oxygen. So in this case, we're already on the mole highway, so we don't have to do any mole conversions. That's why it's really important you write your units, because if you didn't write units, you might try to convert this to moles, but if you write the units, you'd realize you don't have to because you're already there. All right, so now we're just going to use the mole ratio, and so from the balance equation, you can see that there are how many moles of oxygen? There are 7 moles of oxygen for 2 moles of ethane, and since we want moles of the C2H6 on the bottom, it's going to look like this. Okay, so 2.47 moles of oxygen, and you can see how the units here will cancel, and we'll get the units we're looking for. All right, so that's just a mole one. Now we'll do some with a little bit more love to them. Ready? All right, so this one's starting with the equation, make it a little easier for you. What mass of carbon dioxide will be given off from an automobile for every 500 grams of pure octane? In this case, I've given you the equation. So sometimes what helps is to diagram it out, literally write the information you know by the substance. So for example, right, in the previous question, we have this many grams of the octane. We're trying to find grams of CO2. If you back up a slide, right, we want to get mass of carbon dioxide, so grams. And then you can literally say, I'm going to get on the mole highway here, and I'm going to use the mole highway to convert to moles of CO2, and then I'm going to get out of moles. All right, so hit the pause button for a second. Try it on your own. All right, now I'm going to go. Ready? So what we're going to do, just to diagram it, we're going to take the grams of octane. We're going to use the molar mass to get to moles in this case. Then we're going to use the mole ratio. Right, and in this case, 16 to 2. If you want to reduce it, you can, but I would say don't reduce it for a while. Just leave it alone and reduce it when you push the buttons in your calculator. Notice also we're not just writing moles, but moles of what? If you're not careful, if you just wrote moles, you might not realize whether or not these are that these aren't the same. And then we're going to go from moles to grams. And so to actually push the buttons on the calculator, it's going to look like this. So we're going to go grams of octane, use the molar mass. Notice how the units cancel, right? And then we go from moles to moles of CO2, and the units cancel again. Then moles of CO2 to grams using the molar mass. Right? So let's try another one. I'm going to give you a moment. You should hit pause. Try on your own to write the balance equation. And again, you can always review that information on equation writing. That was on homework 9. It was 2 sets of slides ago. So I broke off the equations. Hit pause. All right, you're back from pause. Hopefully you got the balanced chemical equation. That should be the balanced chemical equation. Okay. So now we want to diagram it out. Let's kind of see where we are. Make it like a map. All right. So again, write the info about each substance below that substance. So we're told we have 8.65 grams of the sulfuric acid. We want to find how many molecules. So we want to find question mark molecules of the sodium hydroxide. So then what we're going to do to diagram it, we're going to get on the mole highway here, because where we have information, we're going to get off the mole highway here. right? And then use the mole highway or the balanced chemical equation. And then this is going to be the units of our answer. So if we write units in, here's the arrows I just talked about. Now to write the units of the answer, right, we're going from, this is our map, 8.65 grams. We want to write this down. And again, it's really important to do this because I've seen so many people answer the wrong question. Okay, notice it's in molecules too, so think about what you'll use. All right, so going from here, let's go through the steps. All right, so there's my starting thing. Now try to do a step, maybe do the first step. We want to get to moles. So how are you going to get to moles? Hit pause. All right, you're back from pause. So now what we'll do is the next step is we're going to convert to moles, right? So we're going to use the molar mass of sulfuric acid. You should verify for yourself that you can come up with that molar mass. And you'll see how these units cancel. So now we're here on the mole highway. We want to get to here. So think about what you're going to use. Hit pause. All right, you're back from pause. So what we want to do is we want to make the moles of sulfuric acid cancel. We need to get to NaOH, so we'll use the balanced equation. There are 2 moles of sodium hydroxide for every mole of sulfuric acid. And you see how the grams here canceled? I didn't cancel these here. They'll cancel on the next click. But now we're in moles of sodium hydroxide. We want to go to molecules. So think about how do you go from moles to molecules. Okay, hit pause. Try it on your own. All right, hopefully you're back from pause and you tried it on your own. So now the next step is we want to use Avogadro's number to convert to moles. All right, so that would be the last step. And again, I'm sorry, to convert from moles because we want to get molecules. That's why it's really important. If you did this in grams, you might have done it right, but that wasn't what you were asked. You were asked molecules. So it's important to write down the units of the answer so you can get there. So I tried to break this up into steps for you so you can see what's going on. Notice also how the units cancel, and don't forget about significant figures. Okay, try this one on your own. You can hit pause as much as you want. Each click is going to be a moment of pause. So this is a volume of CO2. Think about what is grams per liter. What is that? Okay, from the complete combustion of octane. All right, so the first step is write the balanced chemical equation. Hit pause. Try it on your own. All right, try it on your own. That should be your balanced equation. We did this one a while. Now this is an equation you had to memorize. Combustion or burning means plus oxygen. Remember, when you burn a hydrocarbon, you always form carbon dioxide and water vapor. Learning how to get hints out of a problem. If you forgot that, well, you're told carbon dioxide is a product. So hopefully you realize that since you're told that, maybe that would help jog your memory. Also, certainly hydrogen has to show up. Now to diagram this out, we want to get volume of CO2. If you look at what we have, do we have a unit of volume? Oh yeah, look, we have a unit of volume. So we're going to shoot for liters. But if we set it up like this, here's the information about each substance by that substance. And so always want to go towards the question mark. So if we put in our diagram, we're going to get on the mole highway here. And we have information here, but we want to get here because our question mark is over here. So we're going to get to moles of C8H18, then we're going to use the balanced equation to get to moles of CO2. From moles, we're going to go through this to get to volume. So this has a little extra twist to it, but you guys can totally do this. All right, so that's where we are. So hit pause, try that. Well, here, let's diagram it out. So we want, here's where we're starting. Here's the units of the answer. Why did we choose liters? The question was volume. Liters are a unit of volume. And since we have them, let's put that unit right there. All right, so let's go through this step by step. Do the first step, get on the mole highway. Pause. All right, back from pause, here we go. So we will use the molar mass of octane. Again, make sure you can come up with that on your own. And you can see now we're in moles of octane. We're on the mole highway. Now we want to go to CO2, so what are we going to do next? Hit pause, try it on your own. All right, we're back. That's right, you would use the balanced chemical equation. The 16 and the 2 come directly from the balanced equation. You can always reduce it later. And you can see now the units all cancel. We're in moles of CO2. Now, how are we going to go from moles to liters? We don't have that. We have liters here. So let's think about that. Maybe if you don't know the step here, try doing it backwards. So I'll hit pause and try a step. Right, so I was thinking that I would maybe work this backwards for a step. So I don't know what to do here, but I have liters. So let's put liters in the top. That means the 1.408 is in the bottom. So now if we look here, what unit do we need on top? Everything cancels but moles and grams. So ideally, we would like grams of CO2 here and moles of CO2 here. Grams per mole is called the, okay, hit pause and see if you can put in the last step. All right, back from pause. Let's put it in. You're right, you would use the molar mass. All right, and so this one is a stoichiometry problem with a density problem tossed in, but you've done density before. So just to review it, okay, we get to moles using the molar mass. Okay, then we get to moles of something else using the equation. And again, notice I'm not just writing moles, but moles of CO2, moles of C8H18, because if I was sloppy, I might not realize that these don't cancel. Okay, but if I write moles of what? Also, make sure you remember that the coefficient is only in the equation. Molar mass is always for 1 mole. So now I'm in moles of CO2. I can't do much with moles. I want to get to liters. So I said, well, how about if I put this in here? Oh, there, look, grams, moles, to make them cancel. Oh, molar mass, right. All right. So that's the approach to problem solving. What's nice is stoichiometry, there's not a lot of new stuff here. It's putting a lot of things together. And the putting things together can be very challenging if you've been struggling with any of it. Usually students have more trouble writing the balanced equation than actually doing the math. So I cannot stress to you enough, go back and review writing equations. Keep practicing writing equations. The homework 10 will help, has a lot of this stuff in words, so you'll have plenty of opportunity to practice it. All right, that takes care of these slides. There's another PowerPoint over this material for limiting reactants.